Okay, hello everybody. So working through lab 10 today. This probably won't take too long, so I'm not going to rush or anything, but be plenty of time for questions if you have any. Otherwise, I'm going to just start working my way down through today's lab. There's no go test component here, so we're just going to fill out the functions based on what the instructions say. So I'm just going to get started. Actually, before I get started, the program is already more or less complete in the sense that it will run, it just won't do anything. So if you look down below in main, you'll notice it's already calling all of these functions and then following all of them up with a new line character. So all I have to do is work on the functions themselves. But I'm going to go ahead and run it just to prove the point. Go run. Lab10.go. Anyway, so nothing happens because the functions are still empty, but it is sort of a working program even though it doesn't do anything. Okay, so let's start with the int array one, and I'm literally just going to follow the numbers, and for every number I'm going to do what it tells me to do. The pretty print note, that really just means make some effort to format the output using printf statements to get or maintain good habits, because sloppy output just suggests sloppy work, and we don't want to create that impression for anybody who looks at our work that it's sloppy. So I just believe it creates the right impression for people when they encounter your work in software, that your outputs look nice. Okay, so I'm just going to, right below the comments, I'm just going to do what's being requested. So declare an array of 10 integers named numbers in its zero state. The easiest way to do that is to use the var kind of declaration. And if you remember from singular variables, if I use var and a variable name and a data type, I get a variable of that type in its zero state. So if the data type is 10, an array of 10 integers, I get an array of 10 integers in their zero state. So that's exactly what I want for number one. Number two, use %v to print the array in its default format. So when you see me say use %v, I'm sort of giving you license to not pretty print. %v is just a really handy way when you're experimenting in code to see what's going on with an array. So, and %v is as opposed to %s or %f or %d. %v is simply a way to quickly print out the contents of an array, and Go will sort of do some minimal formatting for you. I wouldn't call it pretty printing, but the instruction says use %v, so that's what I'm going to do. I did this on Tuesday, so this won't be anything new if you watched me on Tuesday or watched the video that I posted from Tuesday. But I'm going to go ahead and run it at this stage. That's the only two things I've done. An array of 10 integers in their zero state, and I've used %v to print it as I was instructed to do, and then I'll go and look and just see what that did. Okay, so that's the one thing it did. So 10 zeros, as expected, it's zero state. This is what the %v does then. It prints out the contents of the array with square brackets on either side. So that's what %v does. That's not necessarily pretty printing, but again, it's when you're experimenting with something like an array, this can be helpful just to sort of quickly see what's going on. Okay, so the length of the array and print it. So this time I'm going to put a message there so I know what I'm looking at. We did this on Tuesday as well. So arrays, the sizes of arrays are integer values. whole numbers. So this array should show size 10 when I print it. Now what some people will do is put a 10 here, which technically is correct, but what you want to get in the habit of doing is never hard coding a number unless you absolutely have to. Let the computer do the work. So instead of hard coding a 10, I'm going to let the computer do the work by using Go's len function to get the len, or length, of numbers. So that will tell me how many elements numbers has. I know that's going to be 10, but this is the good habit to be in, because when you get into a bigger piece of software, if the length of numbers should change and I'd hard coded it, then I potentially could break something. So I want to lean on Go to compute that value for me as a habit. So that will be what the %d value is, and that should show 10. So there's the 10 that I expected the length of numbers to be. So that's number 3. Okay, number 4. This one is painful and repetitive, and it's that way on purpose, just because I think for some people it helps to develop muscle memory and seeing the same thing over and over and over again. For some people, it helps kind of drive the point home. So use array indexing to individually populate the array. So notice it doesn't say anything about a loop. It doesn't. All it says is individually populate the array. What that means is I'm going to have to do 10 things here, 10 individual values using indexing. What indexing means, if you haven't done the reading, is the name of the array followed by square brackets, followed by a value representing which element of the array you want to access. The first element of every array is at index 0. So this is using array indexing to target the first slot, or the first element, or the 0th element of the array numbers. And what I want to do is assign a value at that slot. And I want to assign 10 because that's what the instructions told me to do. So there's a 10 in the 0 slot. I'm going to use array indexing to access the second element, which is element index 1. Indexing in Go always starts at 0, so it takes some getting used to because the numbers are always going to feel 1 off. So what the value I want to write into the array at that index is 20, and then I'm just going to keep going. So the third element, which would be index 2, is 30. The fourth element, which is index 3, is 40. The fifth element, which is index 4, is 50. The sixth element, index 5, 60. The seventh element, index 6, 70. The eighth element, and notice that it's the 8th element, but index 7, and that's because we started at 0, which is what you have to start at in Go. So it feels a little off because you're used to counting from 1 in normal use. But in most programming languages, when we're dealing with arrays, we count from 0. So the 8th element, which is index 7, is 80. The 9th element, which is index 8, is 90. And then the 10th element, which is index 9. The 10th and final element. So notice that it's a length 10 array, and the last element is 1 less than that. And that's always true with arrays as well. If you know the length of an array, you know the last element, because the last element is always 1 less than the length of the array, since they start at 0, is 100. And then the last instruction gives me license to not do a full pretty print. It says I can use %v again to see what happened to the array. So same thing, I'll just look at the array again. What I expect to see the second time is 10, 20, 30, 40, 50, and so on, all the way up to 100, as opposed to zeros. So the second print is just proving that me storing the data in the array actually worked. So I didn't have to pretty print here because the %v kind of let me off the hook, and that's going to do the square brackets and whatever the data is in the array right now. So there they are as expected. The first element, index 0, is 10. And then the last element, which is the length minus 1, 10 minus 1 is 9. That's index 9. That's 100. And then there's some blank lines because the other functions are waiting for me to catch up. Okay, so that's the 5 things that the int array function was asking me to do. And part of this lab is just to sort of call to your attention the fact that you can store anything, any type of data into an array, but an array can only hold one kind of data. So an integer array can only hold integers. A float array can only hold floats, and so on. There's no way to mix the kinds of data that you store into any one array. Okay, so let's work on float array. There's a note here to pretty print, so when I have the opportunity, I will use printf and try to format my output to have good habits about that. Okay, so declare an array of 5 float 64s, name scores in their 0 state. So this is the same thing as I did in int array. That's called scores. It's 5 float 64, and if I use the var style, then I get 5 float 64s in their 0 state. Okay, number 2, I'm not using it. Yeah, that's fine. Let me get that out of the way. Okay, so number 2 is I'm supposed to write a loop that allows me to type in numbers to populate the array. So use a counting loop to prompt for and read in values for the array. When I say counting loop, I mean this. A loop that does a for I equals 0, I less than something, I plus plus. That's what I mean by a counting loop. For us, a counting loop will be for I equals 0, I less than something, I plus plus. Always. The only thing that changes when you use a counting loop in a different location is what goes in the blank spot. What goes in the blank spot is always the length of whatever loop, of whatever array you mean to be working with. So I mean to be working with the scores array, so I'm going to put the length of the scores array in my counting loop. What that does is allow me to generate a series of indexes from 0 up to 1 less than the length of the array. So if that sounds familiar, the first element of every array is 0, and the last element is always 1 short of the length, so that's what that does. And then the plus plus just means do element 0 followed by element 1 followed by element 2 until you reach 1 less than the end of the array, which is the last index value. All right, so I have a loop, prompt for and read in values. All right, so I can prompt for, that's easy. Enter a score. This is a thing that I notice a lot of people struggling with when they first start using loops heavily and arrays. The reason why I wrote this loop is to work on one value of the array at a time, just one. So when I'm inside the loop, I'm in the singular. I'm working on one element of that array now. The whole point of the loop is to let me work on one element, and then the element after that, and then the element after that, until I get to the end of the array. So inside the loop, I'm speaking in the singular. I'm prompting for one score. And I'm going to prompt for one score repeatedly until I get as many scores as I want. So enter a score, enter a score, enter a score until there's no more scores to enter in the singular. Read in values. Okay. So I'm going to do a scan line here. And the trick is I need this input to go into the array. So I need to go into the array at a specific slot. So whereas above with the integer array example, I was hard coding values to store. Now I'm scanning from the keyboard numbers to score. So I'm going to index the array so that the keyboard input goes directly into the array. The whole purpose for the counting loop, by the way, was to give me the index values, this I index. Everybody in programming, by the way, always writes their counting loops with I, and I almost always means index. So for an index starting at 0, counting up one at a time until I reach the end of the array, do things. So I'm going to prompt for a score, and then I'm going to scan that score directly into the array at a given slot. I will start at 0, and then it'll go to 1, and then it'll go to 2, then it will go to 3, then to 4. When it counts up to 5, it will no longer be less than the length of scores, and it will stop. So that will give me my full 5. So that's a counting loop. And then here's prompting for and reading in a value, scanning it directly into the array. 3 says %v to print, so that's nice because that kind of lets me off the hook from more work to pretty print. So maybe I'll say scores here just for fun. What are the scores? And then I'm printing the %v. The nice thing about this is it lets me put the whole array, and it will output the whole array for me. Before I do anything else, I'm going to run that and see if my scores come through. Okay, so here's my loop. Notice it stopped. It's waiting for one score. So I'm going to do 1.1, 2.2, 3.3, and so on. 1.1 should be 5 of them, so I should get up to 5.5 before the loop realizes that's enough. 2.2, 3.3, 4.4, 5.5, and then here's the %v printing out the whole thing, and it has my inputs 0, 1, 2, 3, and 4. Index 0, index 1, index 2, index 3, index 4. Remember, there's no index 5 because this is a length 5 array, and the last index is always the length less 1. Okay, that was number 3. Number 4. Use a range loop to compute the sum of the scores. Okay, so this one raises the bar a little bit. It's a little bit more challenging. So I need to take these scores and compute their sum. To do that, I'm going to need a place to store the sum. So I need a variable to represent the sum of a bunch of float 64s. So I'm going to add them all together and store them in a variable. Now it doesn't tell me I need that variable, but I know there's no way to compute the sum if I have nowhere to store it. So I'm going to declare this sum, and then I'm going to write a for loop. This time I'm using a range loop. And when it says range loop, it means you should see the keyword range in there. So this one reads a little bit different. You're going to range over your full array of scores and then pulling out one score at a time. So I talked about this on Tuesday. On the right, that's plural. That's the whole array. That's all of them. On the left is singular. That's one of them at a time. So as I range over scores, I will get one score at a time. And that's why the loop is here, to get a score and then another single score and then another single score, and it will just step through the entire array until I've grabbed each of the individual scores one at a time. The I part is the index that goes with each score. So the first score index pair that it grabs out of that array will be 0 and then whatever value happens to be there. And then the second one will be 1 and a value, and then 2 and a value, and then 3 and a value, 4 and a value, and that's the end of the array. So I'm going to grab the individual scores. I'm going to use them to accumulate a sum. So plus equals means take that score and add it on to what's currently in sum to grow it or accumulate it. And then this brings up a little trick, and it's actually more of a necessity than a trick. So that's a full-on range loop. But if you notice, I'm never using the I for anything. So if I go into the loop, I realize, oh, I'm not using the I. If you don't use the I, in Go, you're supposed to put an underscore which says I want to ignore that part. So I'm going to ignore the I because I don't actually need that, even though the range loop gives it to me. So this is the proper way to do this in Go, is I'm going to get an I score, an index score pair, but I don't actually need the index, so I can use an underscore which tells Go just ignore that part. Okay, the sum of scores. Well, that's just the sum that I computed, so I'll print that. That's a float. Just for fun, let's do 2 decimal places. There's the sum I computed. I'm going to go ahead and run that before I do 6 and 7, just to see if it still looks okay. 1.1, 2.2, 3.3, 4.4, 5.5, and then I got a sum of 16.5, which probably is right. Yeah. Okay, so there's my sum. So I used a range loop to compute the sum of scores that had been stored in an array. The average of scores. I'm going to use the colon equals style. So the average, every average in the world, everyone knows, is the sum divided by the number of things that you have the sum of, which in this case is 5. I have 5 scores that went into this sum, so the average would be the sum divided by 5. But don't use the number if you don't have to. That 5 is better expressed as the length of the array that I'm using. I should get an error here, but let's see what happens. So there I've computed the average, and then number 7 says print the average. That's also a float. Okay, so I'm getting an error. If you don't have your editor set up like I do, you might not see the error. So I'm going to run this so you can see the error. Okay, right here, mismatched types. So what it's telling me is that the thing on the left, the sum, is a float 64, and the thing on the right, the length, is an integer. But we know how to do this. If we have an integer where we actually need a float, then we can just force it to be a float. So I'm going to take the length and force it to be a float, and then I can compute my average off of it. And 3.3 is what we'd expect, that being the median and the average at this point. Okay, so that's the float array stuff. That has a counting loop, which it would benefit you to spend a little bit of time thinking on. So that you get used to what I mean when I'm talking about a counting loop. There's also a range loop here, which again, it's helpful to sort of spend some time practicing that and thinking about it if you can make yourself do that. That's the float array. The string array. So this is also just a reminder that when I have an opportunity, I should try to format my output decently. Okay, so this one, the instructions change a little bit because it says to declare an array named greetings that's pre-populated. So pre-populated means with starting data as opposed to in its 0 state. So I'm going to do it wrong first. that is a string array in its 0 state, which would be 3 empty strings. But it tells me to pre-populate it with some greetings of my choice. So instead of using the var style, which will 0 state it, I'm going to pre-populate it. And the way you do that with arrays is by filling in curly braces with the required number of things that match. So I need to populate this with 3 strings. And not empty ones, but like howdy, hello, hiya. That's a pre-populated array. So notice I didn't use the var style because that would 0 state the data inside of it. I populated it with 3, because it's a size 3 array, strings of my choice. I stole the howdy from the example. So that's it's showing an error right now because I'm not using it, but that's fine. Okay, so that's part 1. This one only has 2 parts. Part 2 is a range loop. So a range loop, I'm always going to get an I paired with something as I range over something. So the thing you're ranging over is the plural thing, which in this case is all of those greetings. That's what I'm ranging over, stepping through to grab the individual elements. As I do that, I get singular things, a pair of index and the singular of what comes out of the greetings. So one of those things I would refer to as a greeting because I speak English. A singular greetings is a greeting, one of them. Many of them, that's an array. One of them, that's what I get as I range through the array. So I'm going to get a pair of index and greeting. So howdy will be index 0, hello will be index 1, hiya will be index 2. If you notice the example, oh, I said hiya instead of hi. That's fine, instead of my choice. When I said howdy is at index 0, hello is at index 1, and hiya is at index 2. So if you notice, these numbers pair up with the index values that I get when I range over the array. So what this is really telling me to do is print the individual greeting and the index together, followed by a new line. So I'm going to do that. I'm supposed to put square brackets with an index, which is an integer, a whole number. And then I'm supposed to put a string, which would be the greeting. So index, that will fill in the %d. So I'm using that I now. And then the greeting, the single greeting that I'm getting. So in the loop, singular, one thing at a time. So I'm going to print both parts of that pair. The index inside of square brackets, and then the greeting that goes with that index. So there's the 0 for howdy, the 1 for hello, the 2 for hiya. So I'm actually printing out the indexes that are paired with the individual greetings. If I read the notes, I'll see example says 0, 1, and 2, but better is 1, 2, and 3. So this is just a trick that you'll see programmers do all the time, which means you're going to do it. Normal humans aren't accustomed to counting from 0. So sometimes when we're making software, we do little tricks to make it look like what normal humans expect. So normal humans wouldn't expect 0 or 1 or 2, they'd expect 1, 2, or 3. And the easy way to pull off that trick is to take the index and just add 1 to it. That doesn't change the index, it just makes it appear to be 1 bigger than it actually is when it's being printed. So there they are as 1, 2, 3, and that's really just a trick of the eye that I pulled in code. And that's all that string array asked me to do, was those two things. Notice if you take all my commenting out, by the way, there's very little code, and this is one of the beautiful things about arrays, is the amount of information you can process with a lot less code than you'd think. Okay, last one. So this one's called parallel arrays, and I'll describe it as I do it. There's the note again, make some effort to make pretty output. Okay, so declare an array of 5 string name products and pre-populate it with stuff. Okay. So pre-populate means that I will use the colon equal style to set up my 5 string array, and then I'll populate it with data. Bread, milk, eggs, butter, sugar. Hopefully that's not too tiny from where you're looking at it. Okay, so there's a pre-populated string array. Bread is at index 0. Milk is at index 1, eggs at index 2, butter at index 3, sugar at index 4. I'm saying that now because that's going to be useful here in just a second. So number 2, an array of 5 float 64 named prices that's pre-populated. So prices will be pre-populated. It's an array of 5 float 64. So what I put in here is now floats, not strings. I'm just going to steal these prices from down below. The price of eggs, by the way, has gone up quite a lot. Okay, so there's my 5 prices. So now I will explain to you what I mean by parallel arrays. Parallel arrays. What I mean by parallel arrays... no. So where you do need that, so if you were set up like this, then you would need the comma. So if that curly brace is sort of further down the page, then you do need a comma. If it's all mushed together on one line, then you don't. Hopefully that makes sense. But what you'll when you get like real arrays and big arrays, you often have the closing curly brace down below, and in that case, you absolutely do have to have a comma. Oh, I'm sorry, I've messed it up a little bit. Okay, you're seeing the red lines because I'm not actually using those things yet. Okay. So what do I mean by parallel arrays? What I mean by that is that I have 2 or more arrays where the data in the 2 arrays or more arrays line up in parallel. So the product at index 0, bread, its parallel data is the price at index 0. So bread at 0 and products is $1.98 at 0 and prices. Those are in parallel. So milk at index 1, I would expect to find its price at index 1 in the prices array, which is the idea. Eggs at index 2, its price will be at index 2 in the price array. Butter is at index 3 as products. Its price will be at index 3 in prices. So I'm actually sort of storing related data in 2 different arrays, but the indexes are the same location. So sugar at index 4 in products, its price is at index 4 in prices. To have parallel arrays, it works best, by the way, if they're the same size. So if I have 5 products, then I should have 5 prices in parallel. But that's not an uncommon thing to do. I have 2 or more arrays where I'm kind of lining up in parallel data between them. Okay, and then the last bit is the counting loop to print out something that looks cool like this. Counting loop is a for I equals 0, I less than something, I plus plus. That's a counting loop. And then what goes here is the length of something. So this one throws people off, but it's designed to throw you off a little bit just so you sort of have seen this situation. What I mean to be doing is printing products and prices, the two pieces of data from two different arrays. But I can't write a counting loop on two arrays. I just can't. So I just have to pick and hope that they're the same size. I know they are because I can see that, but I'll just take the length of the products. But I know that the length of the products is the same as the length of the prices, so it's going to work out okay. And these are parallel arrays, so as long as I have the length of one of the arrays, then the parallel arrays should all line up just fine. Okay, so what am I supposed to print? A product and a price. First, I'll just set up the template. So a product followed by a colon, followed by a space, a $sign, followed by a price to 2 decimal places. And then the only other problem is, where does the product name come from? That comes from the products array. And the reason I wrote the counting loop is so that I could access by indexing the individual product names. So when this I is 0 in the counting loop, I will be working on bread. And that's nice because when I is 0 for products, it's also going to be 0 for prices, which is the price that I want from the prices array, is the one at the same location. So I'm going to get the products at an index and the prices at the same parallel index. I noticed that the pretty printing does a thing, so I might sort of finish with that thought, but let's see what we get here. But notice I really could only write the counting loop. I had to pick one of the parallel arrays, but then inside the loop, I am using both of them to print out the parallel pieces of information. So there they are. Those don't look super nice, by the way. They're not all lined up, and I sort of will just show you how this works. You can actually format strings. So let's see, what's my longest string? Is 6 characters right here, butter. So if I put a 6 right here, watch what happens. So notice how they all got sort of right aligned to 6 spaces, which is a way to kind of make that look slick. So you can actually put numbers in between the percent sign there, and you can sort of make column widths with it. I think that's everything, isn't it? I believe that to be everything. So now I'll open up for questions. Let me put a note in here so that you know I'm about to do that. Okay, so that's the whole lab. Now I can entertain your questions. Yeah, get uniques. Challenging. So we can work on that one. Let me pull up lab 12. I think that's the hardest one. Did I turn on my audio? I did. I believe that this is the hardest one. So it makes sense that that would be where sort of you got to where you thought, wow, this one's nasty. Okay, so this one really sort of does. I think it's a pretty neat computer science problem. It's just a neat problem in computer science thinking to solve. So my job basically is to produce a set of results that is all of the words from this original list that are without duplicating any of them. So what I mean by that, at least I think this is what I mean. So if, as an example, if my list is apple, banana, apple, apple. Is that right? Use a slice containing only non-duplicate strings from a given list. I think this is my intention. So if I'm given a list to start with that's apple, banana, apple, apple, cherry, my results would contain apple, banana, cherry. So it would only have the apple once, as opposed to more than one time. I think that's my intention for this, if that makes sense. So by unique, I mean don't pull copies of words. Don't pull the same word more than once from the original list. Just get a set of results where every word in the results is a unique word, where it's not duplicated. So the original list may have duplicated words. The results lists should not. Okay, so the way you do that, you gotta loop through, and I'm going to use a range loop for this. So I'm going to range over the original list. And the whole trick to this, it tells me to use contain string as a helper. So contain string, if you give it a list and a string, it will tell you if that list already has it. So the whole trick here is to only take strings from this list that you don't already have in your results. And the way that looks like is if it does not, is how we do this in sort of fancy code, contains string. So if my results do not already contain a given S, this is how you avoid the duplicate. So if my results slice does not already contain this string from the list, then I'm going to add it to my results. That's the whole trick. So I'm constantly looping over the original list, and then for each string I pull from the original list, if I don't already have that string in my new list with the results in it, then I add it. That's what the bang here, the exclamation point, means if I do not contain that string. So if my results doesn't already have S, then I add it. If my results does have S, then I don't end up appending it, which is how I prevent duplicates from getting in there. This is kind of a cool trick. If you think about it, this is how you would do it if someone gave you pencil and paper and had you solve this problem. It's just harder to explain to a computer how to solve this problem for itself. But if you were writing it down on paper, if you think about it, if I gave you a list and I say, make a new list, but don't write any word more than once from the original list, that's what you'd do is you'd read down through the original list, and then you'd look in your new list to see if you'd already written that word down, and if you hadn't, you would write it down, and if you had, then you wouldn't write it down, you'd move to the next word. So that's how this one works. Yes, you can do a counting loop. That's perfectly fine. Yeah. That's totally just a matter of what you personally prefer. I don't know what that is. You have to copy the whole function in. I can't. Um, you're probably missing a parenthesis or a curly brace somewhere. But if you just paste the whole function in, we'll find it. Yeah, this part right here. So this is in the wrong place. And also not a double equals. So that means that this one's too many. So there's one too many curly brace and you had this thing in the wrong place. Oh, don't worry about my errors. They're not related to this. Not quite. It's a slightly different algorithm. So like link the shortest actually has to read through all of the strings in the slice and find the shortest one and return that length. Right? So So these are different. These are just returning one number, which is the length of one string. If that's the ones you're referring to. Okay, I'm gonna sign out. Looks like we're mostly run out, so I'll be back here. You can always email me if you have questions in the meantime, but otherwise I'll see everybody on Tuesday next week at 2 p.m. So have a good weekend.